All right, I'm going to try to explain the math here to figure out my coefficient of demand elasticity and will my total revenue go up or down if I raise my prices. It depends if people will still buy my product even though I raise the price. So here we're going to take a look at this will be a question on the test. The math isn't that hard, just a couple simple formulas. So in this theory, I've got my quantity sold. I'm going to go from 1,000 sold to 900 sold by raising my prices from, make these look like dollars, $100 per item. I don't know, let's say I'm selling some kind of shoes or something. And then I'm going to raise my prices by, obviously here, 30%, right? Oop. That was a mistake. I want to make it a dollar sign. Fine. So I want to find my coefficient of demand elasticity. This is not going to be a good idea, right? Actually, it will be a good idea, excuse me. If I'm going to raise my prices by 30%, but my quantity sold isn't going to go down that much, this is a good idea. It should raise my total revenue. So let's just take a look at the math that we use. So I want to find the percent change. This is basically it's a 10% drop, right, of quantity demanded. So how do I know that formula? Because again, on the test, they're not going to be these nice, easy round numbers. I take the newer figure, right? Here's my new quantity, 900, minus the old. I put parens aren't in Excel, but in a calculator on the test, you just throw in these numbers, divided by the old, right? New minus old divided by old, right? Remember that one for the test, percent change. And it comes out as a negative 10%. Again, we're going to kind of ignore the negatives here in a second, but because we just want to work with the absolute number, the whole number. And I want to find the same thing. What's the percent change in price, right? So I'm going to do my same thing, the new number minus the old number, divide by the old number, right? And there's my 30% rise in price. So the coefficient of demand elasticity, it's the percent change of quantity divided by the percent change in price. So to finish off this formula, I take this 10% divided by the 30%, and my coefficient is 0.33. And again, I don't care about the negative numbers, so in Excel there's a way of getting rid of this. I'm going to use the absolute function. Do you know using an absolute of a number? This is from 9th grade math. Maybe you remember it. And it just has the 0.33 instead of the negatives. So here, I want to see actually how the old and the new changes my total revenue, right? My old quantity, my old price, my new quantity sold, and the new price. So total revenue is fairly easy, right? It's just the quantity sold times the price. I sell $1,000 of these shoes at $100 a pop, and $100,000 is my total revenue. So for my new, I take that 900 sold now times the new price of $130. So here my total revenue went up $117,000. So here the coefficient of demand elasticity, and if you look on page 115 in the textbook, this is basically what I'm taking a look at. The coefficient of elasticity is less than 1. This is the middle line of the textbook here as I'm reading it. Price goes up a lot, quantity goes down a little, and total revenue goes up a lot. You notice there are some lines here next to the P, Q, and TR. So here, let's take a look at if it is the other way around. If it's inelastic, right? I sell my, raise my prices, and quantity demanded goes down a lot. Like say, if well, same thing, we raise it by 30% here, but the quantity demanded, let's say people just stop buying it, 600. They don't go for my shoes, they go for somebody else's shoes. Boom. So again, here we can see the percent changes automatically in Excel, right? So it's the 40% change of quantity by the 30% of price. My coefficient of demand elasticity, again, which just takes the 40 divided by the 30, comes out to 1.33, or it's greater than 1. right? And again, this is the first case one on page 115, right, where the coefficient of elasticity is greater than 1. The price goes up a little bit, again 30%, compared to the quantity drop that goes down a lot, 40%. So then my total revenue went from $100,000 to $78,000. So you can play around with this spreadsheet. Again, this is what merchants do when they want to take a look at how change in price affects the quantity demanded. Will people still buy your products? Sometimes, again, it's going to play around here a little bit. Like say I raise my price to 150 bucks. I have some shoe that people have to have. And then the quantity demanded just changes by a little bit, 950. Right? My coefficient of demand is way less than 1%, or excuse me, less than 1. Again, 1 is unitary elasticity, where if there's no change in total revenue, basically. But here my total revenue went from $100,000 to $142,000. So again, my quantity change went down a little, my price went up a lot. Or same thing around if I lower my prices, right? Maybe if I lower my prices to $90, I get a $90 lower price. Maybe, like say, well, let's say a lot of people buy more because then this shoe becomes competitive with somebody else. I'm going to say they're going to sell 1,200 of these, right? Again, my coefficient of elasticity is over 1. So again, here when the price goes up a little bit and the quantity change goes up a lot, right? This is very elastic. So again, the total revenue goes up. So take a look at the spreadsheet, do the formulas yourself, and then compare it to page 115. This demand elasticity. But I'll go over it in class also.